Today we're going to solve an interesting problem involving complete combustion. And compared sa mga previous problems na sinagutan na natin, this will require us to dig a little bit deeper. How are we solving problems na mayroong mga excess O2 or excess air, and then meron din tayong oxygen dito sa ating coal or sa ating fuel. So let us start by analyzing muna yung ating problem. So we have here a coal containing 68.2% carbon, 4.5% hydrogen, 0.7% sulfur, 1.7% nitrogen, 7.8% oxygen, 4.4% ash, and 12.7% water. And we burn this in a furnace. The product of combustion, a dry gas analysis, we have CO2, which is 14.4%. We have an oxygen, which is 4.6%, and the rest is nitrogen. So we have to calculate first the theoretical volume of air used to complete combustion of 100 kg of coal. So given na yung weight ng ating coal, no, yung ating fuel. Then we have to determine yung theoretical volume ng air na ginamit for complete combustion. And then finally, we need to get the percentage of excess air used. Okay, so katulad ng dati, no, para hindi tayo mahirapan, let us draw a diagram first, no, para ma-visualize natin yung ating situation. So we have a furnace. And then, ang ating fuel is 100 kg of coal. Okay, so we have 100 kg of coal. So, given sa atin yung composition ng ating coal, no? So, we have carbon, which is 68.2%. We have hydrogen, which is 4.5%. We have sulfur, which is 0.7%. We have nitrogen, which is 1.7%. We have oxygen, which is 7.8%. And we have also ash dito sa ating coal, which is 4.4%. And then we have water, which is 12.7%. Okay, so ang ating product, we have carbon dioxide, which is 14.4%. And then we have O2, which is 4.6%. The rest is nitrogen, N2, no? And then, sabi nga dito sa ating requirement 2, we have excess air, no? So, we have air here plus excess. So, kailangan nga natin i-determine yung percentage of excess air natin dito. Okay, so alamin muna natin kung gaano karaming N2 meron tayo dito sa ating product. Given naman kasi yung percent ng ating CO2 and O2. So let us check ilang percent ng N2 meron tayo sa ating product. So 100% minus 14.4. Okay, then minus 4.6. So we have 81% of N2 now. Okay, so yan ang ating given. Now, since given ang ating weight ng ating coal, so therefore, we can determine yung weight ng ating mga components dito. Okay, so, para hindi na tayo mahirapan pa, no? Sulat na natin dito yung mga weight natin. Carbon is 68.2 kg. Hydrogen is 4.5 kg. Sulfur is 0.7 kg. Nitrogen is 1.7 kg. Oxygen is 7.8 kg. Ash is 4.4 kg. And water is 12.7 kg. Okay? So, ang unang pinahanap sa atin is yung theoretical volume of air used for the complete combustion, no? So, yan ang una nating aalamin. Theoretical volume of air for complete combustion. Alright, so alam natin kapag meron tayong complete combustion, lahat ng ating combustible material has been gasified or completely burned, no? So identify natin alin ba dito sa ating mga components ng ating coal ang mga combustible materials. So we know that carbon is combustible, hydrogen is combustible, sulfur is combustible, the nitrogen is not, oxygen is not, ash is not, and water is not combustible. So, ito lang yung mga combustible materials natin. So, anong mga reactions meron tayo? So, for complete combustion, we have carbon plus O2 producing CO2. Sulfur plus O2 producing SO2. And then, for H2, it will be reacting to 1/2 of O2 producing water, diba? Now, natutunan natin sa ating previous lesson that in order to get the required oxygen for the combustion, kailangan makuha natin itong total O2 na nagamit natin in burning all the carbon to CO2, burning all sulfur to SO2, and burning all H2 to H2O. So, kailangan makuha natin ito, no? Itong total O2 natin dito. So, that means, in order to get the required oxygen, so, the required O2 is equal to the O2 for the burning of carbon plus the O2 for burning of sulfur plus the O2 for burning of hydrogen, ano? Or H lang kasi isang atom lang yung nandito sa ating solid na fuel, no? Okay, so ngayon kailangan nating makuha yung number of moles ng ating O2 for carbon, number of moles ng O2 for sulfur, and number of moles ng O2 for hydrogen, no? So, unahin natin yung number of moles ng O2 for carbon. Okay, so gaano karaming oxygen ang kailangan natin to convert all the carbon na nasa ating fuel to CO2. So, alam natin that our carbon is 68.2 kg, no? So, we have here 68.2 kg. Then, we're going to divide this to its molecular weight. So, in 1 kilogram mole of carbon, we have 12 kilogram of carbon, ba? So, dahil 1:1 ang ating carbon sa ating CO2 and 1:1 from carbon to O2, so that means ang ratio natin dito is 1 kilogram mole of carbon to 1 kilogram mole of O2. Okay? So, tignan muna natin yung ating dimension. So, we have kilogram of carbon will be cancelled out. Kilogram mole of carbon will be cancelled out. So, ang maiwan sa atin is kilogram mole of O2, which is, we are going to solve. Okay? So, we have 68.2 divided by 12. So, we have 5.68 ng ating kilogram mole ng O2, no? Okay, next, we need to get the O2 for sulfur. So, ilan ang weight ng ating sulfur sa ating fuel? We have 0.7 kilogram. No? So, we have 0.7 kilogram of sulfur divided by its molecular weight. So, in 1 kilogram mole of sulfur, we have 32 kilogram of sulfur. So, para makuha natin yung oxygen requirement, titignan natin sa kanyang reaction. So, 1:1 lang ang ating sulfur to O2, no? So, for every 1 kilogram mole of sulfur, we have 1 kilogram mole of O2. Okay? So, tignan ulit natin yung ating mga units. We have kilogram of sulfur, kilogram mole of sulfur. So, ang maiwan sa atin is kilogram mole of O2, and then we'll solve for that. We have 0.7 divided by 32. So we have 0.021 1 or 0.022, okay, 0.022 kilogram mole of O2, okay? And then, para naman sa O2, for converting our hydrogen dito sa ating coal. So, we have 4.5 kilogram ng hydrogen, no? 1 atom lang ng hydrogen. So, 4.5 kilogram of hydrogen. Divide natin sa kanyang molecular weight. So, 1 kilogram mole of hydrogen is 1 kilogram of hydrogen. Okay, so tandaan natin, no, single unit lang ng hydrogen meron tayo dito. So, that means, since H2 ang gamit natin dito, that means we have for 2 kilogram mole of H, we have 1 kilogram mole of H2, di ba? So, that means, dito sa ating reaction, ang ratio ng H2 to O2 is that 1 kilogram mole of H2 is 1/2 kilogram mole of O2. Ba? So, tingnan ulit natin yung units natin. Kilogram of hydrogen, kilogram mole of hydrogen, kilogram mole of H2. So, we have kilogram mole of O2, no? So, we'll try to solve that now. We have 4.5 divided by 2, no? Meron tayo ditong denominator na 2. So, divided by 2. Then, multiply to 1/2. Okay? So, that means we'll be dividing this by 2 as well. So, we have 1.125 kilogram of O2. Yan yung O2 na kailangan natin to convert our hydrogen sa ating coal into water. Okay? So, that means makukuha na natin yung O2 required, no? So, our O2 required is equal to the amount of oxygen for carbon, which is 5.68 kilogram mole of O2 plus 0.022 kilogram mole of O2, then plus 1.125 kilogram mole of O2. Okay, so this is kilogram mole, no? So, this is kilogram mole. So, ilan ang ating required O2 for complete combustion? So, we have 5.68 plus 0.022 plus 1.125. And this is equal to 6.827 kilogram mole of O2. Okay? Now, we have to take note that we already have an oxygen dito sa ating coal, no? Kasi, itong nakuha nating required O2, yan ang amount na oxygen na kailangan natin for complete combustion. And we know that already, no? Nakuha na natin yung value niya. But we will not get all of this oxygen sa air. Dahil yung coal natin mismo, meron na siyang oxygen. So, we're going to consume this first. Okay? Dahil nandito na siya present sa ating coal. So, that means we have to subtract that dito sa ating nakuhang required O2 para makuha natin yung theoretical O2 required from air. Okay, so, kailangan nating makuha kung gaano karaming O2 yung nasa coal. Okay, so, alam natin yung oxygen natin sa ating coal is 7.8 kilogram. Okay, and this is single atom, no? So, 7.8 kilogram ng oxygen. And then, we're going to divide that sa molecular weight ng oxygen. For 1 kilogram mole of oxygen, we have 16 kilogram of oxygen. But, ang kailangan natin is O2 gas, no? So, for every 1 kilogram mole of O2, we have 2 kilogram mole of oxygen, no? So, let us check our units. Kilogram of oxygen, kilogram mole of oxygen. So, we have O2 now. Okay, so let's check. So we have 7.8 divided by 16, then divided by 2. Okay, so that means we have O2 in coal, which is 0.244. Okay, so katulad ng sabi ko kanina, ito yung O2 na nasa coal na mismo. So we need to subtract that dito sa ating required O2 for complete combustion para makuha natin yung theoretical O2 for complete combustion. So theoretical O2 is equal to 6.827 kilogram mole minus 0.244 kilogram mole. Okay, so the theoretical O2 is equal to 6.827 minus 0.244. So our theoretical O2 is 6.583 kilogram mole of O2. Okay? So dahil alam na natin yung theoretical O2, that means we can get the theoretical air na needed for our combustion. So we have 6.583 kilogram mole ng O2. And then, we know that sa ating air, we have 0.21 of kilogram mole of O2 for every 1 kilogram mole of air, no? So, yan yung ratio ng ating oxygen sa air, okay? Because we know that our air is composed of 21% oxygen. So, this will be cancelled out. So, ang magiging sagot natin dito will be 6.583 divided by 0.21. So, we have 31.35 kilogram mole of air. Okay, so, alam na natin kung ilang mole ng air meron na tayo, no? Or ilang mole ng air ang kailangan natin i-supply for complete combustion. Pero ang pinahanap sa atin is yung theoretical volume of air for complete combustion, no? So, how are we going to get itong theoretical volume ng air natin? Paano natin makukuha yan? Well, we can get this if we are going to assume that we have an ideal gas at STP, or standard temperature and pressure. So if we have an ideal gas, we're going to use the ideal gas equation, which is PV is equal to nRT. So we have here the number of moles ng air, no? So we need to get our molar volume, which is the volume per mole of our air. So therefore, we need to get V over N is equal to RT over P. And since we are at STP, therefore, our temperature is at 273.15 Kelvin, and our pressure is 1 atmosphere. Okay, so therefore, our molar volume is equal to our R, which is 0.08205 liter atmosphere per mole Kelvin, times 273.15 Kelvin divided by 1 atmosphere. Okay, so tignan natin yung units natin. So our atmosphere and Kelvin will be cancelled out. So ang magiging unit natin is liter per mole. Okay, so try natin i-solve yan. We have 0.08205 times 273.15 divided by 1. Okay, so we have 22.4. Sorry, I'll have to use white. So this is 22.4 liter per mole. Okay? And then, since naka-kilogram mole tayo rito, no? So, we're going to convert that. So, we have 22.4 liter per mole. Okay, so this is gram mole. Dahil yung ating value ng R here is in gram mole. So, we're going to multiply this. We have 1,000 gram mole per 1 kilogram mole. Then, we have 1,000 liters per 1 cubic meters, no? So, yung mga units natin magka-cancel out lang actually. Okay? And then, liters. So, ang ating 1,000 will be cancelled out. So, pareho lang actually yung value natin. So, our Vn is equal to 22.4 cubic meters per kilogram mole. Okay? So, yan ang gagamitin natin to convert itong theoretical air natin. So, we have 31.35 kilogram mole of air. Okay? So, we have theoretical air is equal to, sorry, kalimutan ko. We have 31.35 kilogram mole. Okay? So, therefore, ang theoretical volume natin, yan ang kailangan nating makuha, no? So, let's just review. Theoretical volume of air for complete combustion. So, our theoretical volume is equal to 31.35 kilogram mole of air times 22.4 cubic meter of air per 1 kilogram mole of air. Okay, so this will be cancelled out. Okay, so therefore, ang magiging sagot natin is 31.35 times 22.4. So we have 702.24 cubic meter of air. So yan ang ating theoretical volume of air. Okay, so ito yung answer natin for the first problem. Okay. So, nakuha na natin yung theoretical volume ng air. We are now going to solve yung second problem. At ang pinahanap sa atin dito is yung percent excess air na ginamit natin, ano? Dahil meron tayong in-apply na excess air. So, alam na natin kung gaano karaming air yung gagamitin natin. We know that the theoretical air is 31.35. So, ang kailangan nating makuha is yung percent excess air used. Okay? So, tandaan natin, given na yung percent ng ating product. Okay? So, therefore, pwede nating makuha kung ano yung weight or kilogram mole ng ating product, no? Itong buong product natin dito. Okay? So, let us take note of this. We have 14.4% ng CO2, 4.6% ng O2, and 81% ng N2. No? So, yan ang ating product. So, let me write that dito sa baba. So, okay, ang ating product, we have CO2, which is 14.4%, our O2, which is 4.6%, and our N2, which is 81%, diba? Yan ang ating product. Now, let us go back sa ating complete combustion reaction. So, our carbon reacting with O2 producing CO2. Okay? And alam na natin kung ilan ang kilogram mole ng ating carbon, di ba? Ito na yun sinolve natin kanina. our carbon is actually this one, 68.2 divided by 12. Okay, so pwede nating makuha kung gaano karaming carbon meron tayo. Okay, so our carbon is 68.2 divided by 12. Okay, so para hindi kayo malito, let me write that here. Okay, so yung number of moles ng carbon is 68.2 kilogram of carbon. Divide natin sa molecular weight niya. So we have 12 kilogram of carbon for every 1 kilogram mole of carbon, diba? So, itong ating unit will be cancelled out. So, ang magiging sagot natin dito is 68.2 divided by 12. So, we have 5.68 kilogram mole ng carbon. Okay, so let me erase this. So we have 5.68 kilogram mole. So 1:1 tayo, so that means our CO2 is also 5.68 kilogram mole, di ba? So if we have 5.68 kilogram mole, and that is 14.4% ng ating product. Okay, so this is our product. So that means you can get kung ano ang number of moles ng ating product. And let's say that is X. Okay, so that is the number of moles ng ating product. So what do we mean by that? So if our product is X, 14.4% of that, so 0.144 is equal to the number of moles ng carbon. Dahil 1:1 naman siya. So that means this is 5.68 kilogram moles. Okay? So that means our X, which is the number of moles of our product, is equal to 5.68 divided by 0.144. Ito. Okay, so we have 39.44 kilogram mole ng ating product. So we have here X, which is 39.44 kilogram mole. Okay, so nakuha na natin yan. So if you know this, that means you will be able to find out kung ilang kilogram mole ng O2 and kilogram mole ng N2 meron tayo, no? If you're going to look at this diagram, so as you can see, our nitrogen is coming from air and coming from the coal, which is we have 1.7 kilogram of nitrogen. Okay, so that means in order to find kung gaano karaming nitrogen meron tayo dito sa air, we need to subtract 1.7 kilogram or the number of moles of nitrogen dito sa ating coal, dito sa number of moles ng nitrogen dito sa ating product. So kapag sinubtract natin ito, number of moles ng nitrogen sa number of moles ng ating nitrogen dito sa product, we will get the number of moles of nitrogen dito sa air, no? So let us do that. Alam na natin kung ilan ang kilogram mole ng ating product. We have 39.44 kilogram mole. So we need to get the number of moles ng nitrogen, no, into gas sa ating product. Okay? And this is equal to, we know that our nitrogen is 81% ng product. So we have 0.81 of 39.44 kilogram mole. Diba? So what is that value? So we're going to multiply 0.81 times 39.44. So we have 31.95 kilogram mole of N2 in our product. Okay? Now, gaano karaming N2 meron tayo sa coal? Okay? So, ang sabi natin, ang nitrogen natin sa coal is equal to 1.7 kilogram. Diba? So, in order to get yung number of moles ng N2 sa coal, we have 1.7 kilogram nitrogen. Divide natin sa molecular weight niya. So, we have 14 kilogram ng nitrogen or 1 kilogram mole ng nitrogen. Then, N2 ang kinukuha natin. So, we have 2 kilogram mole of N per 1 kilogram mole of N2. Okay, so, check natin yung ating mga units. Okay, this will be cancelled out. So, maiwan is kilogram mole ng N2. Okay, so, to solve this, we have 1.7 divided by 14 and then divided by 2. Okay, so we have 2 here. So, divided by 2. So, we have 0.0607 kilogram mole ng N2 sa coal. Okay, sa coal yan, no? Now, in order to get N2 in air, we need to subtract yung N2 in product sa, okay, by the N2 in coal. Diba? So, in-explain na natin yan kanina, but let me draw para hindi tayo malito, no? So, yung coal natin may nitrogen na 1.7 kilogram, which is, kinalculate natin dito, nitrogen in coal is 0.0607 kilogram mole ng N2. And then, ang product natin, we have 31.95 kilogram mole ng N2. 95. Okay? So, saan ang galing yung rest of N2? It's coming from air. So, we have N2 from air. Ayan yung kailangan nating makuha. So, this is the one. N2 from air is equal to N2 ng product minus yung N2 coming from the coal, no? So, let us now try to solve that. Okay, so N2 from air is equal to yung N2 sa ating product, which is 31.95 kilogram mole, minus the N2 from our coal, which is 0.0607 kilogram mole. Okay, so that means it is, okay, 31.95 minus 0.0607. So we have 31.8893 kilogram mole of N2 in air. Okay? Now, in order to get yung percent excess natin, okay, so we learned from our lecture the percent excess air. Formula natin dyan is equal to O2 supplied minus the theoretical O2 over the theoretical O2. Okay? Times 100. Okay? So, kailangan makuha natin yung O2 supplied. So, yung O2 supplied will be calculated based from the N2 on the air, no? So, yung O2 theoretical, alam na natin. Nakuha natin yan dito. Sa unang calculation natin. So, we have here the theoretical O2, which is 6.586 kilogram mole ng O2, no? So, sulat natin yan. So, theoretical O2 is equal to 6.586 kilogram mole ng O2. So, ang kailangan nating makuha is yung O2 supplied coming from air. So, alam na natin yung N2 from air, no? So, para makuha natin yung O2 from supplied air, we need to get yung ratio niya, no? So, we have 31.8893 kilogram mole ng N2 sa air. So, sa ating air, we have 0.79 kilogram mole of N2 per 0.21 kilogram mole of O2. Okay? So, yung unit natin, this will be cancelled out. So, our O2 from air will be equal to 31.8893 divided by 0.79 times 0.21. So, our O2 from the air is 8.48, no? So, we have 8.48 kilogram mole of O2 from air, no? So, makukuha na natin yung percent excess air. So, ang formula natin, O2 supplied, which is the O2 from air, which is 8.48 kilogram mole of O2, minus the O2 theoretical, which is 6.586 kilogram mole ng O2, divided by yung theoretical O2. So, divided by 6.586 kilogram mole of O2. So, therefore, our percent excess air, okay, so this will be multiplied to 100. Natin pwedeng kalimutan. So, let us solve for that. We have 8.48 minus 6.586 divided by 6.586 times 100. So, we have 28.76%. Okay, so ito yung ating final answer. So, our percent excess air is equal to 28.76%. So, I hope marami kayo natutunan dito sa sinagutan nating problem. And we will be solving more problem about combustion on the succeeding videos. So, until then, thank you very much for watching and have a nice day.